Lesson 20, Curve Sketching 5, Concavity Change. Now here we'll have a situation here when you'll see that you've got a cubic curve at x equals 0. This is the point 0, -1. And you'll notice something. The curve is concave up here, concave down on this side. When this occurs, this point has got a special name. It's called a point of inflection. Inflection sometimes with a C, but I think the X is the way to go. Now, to determine whether it's a point of inflection or not, first of all we work at the first derivative, and we get 3x squared. Now, if we look at the second derivative, we get 6x. Now we'll let the second derivative equal 0. Okay, so we get 6x equals 0. And what we're saying here, at that particular point there is no change. Yeah, in other words, it's neither positive nor negative, so it can't be a maximum or a minimum. So the only thing you've got left is a possible point of inflection. So x equals 0, we go either side epsilon, so this is the second derivative, and we look at the negative, and we can see here we've got, putting in the negative, we can see the second derivative is negative, this is 0, and here we put the positive epsilon, and we'll see it's going to be positive, or positive epsilon if you like. 6 and minus 6 epsilon. And we'll see that there's a concavity change from negative, concave down, through to positive. So we must have what's called a point of inflection at that point. Now it's very important to provide this test because you may get the second derivative being 0, but there's no concavity change. In fact, you can see that situation with y equals x to the 4th. When you differentiate that, you get 4x cubed. Do it again, and you get 12x squared. Right, so when you let that equal 0, you'll see, okay, you get a 0 for the second derivative. But when you put in the epsilons either side, this squared changes this to a positive. So you get a concave up on both sides, which, well, that's what you expect with y equals x to the 4th. We're going to get that situation when it's concave up either side. But if you just relied on letting the second derivative equal to 0, then that would not really confer that was a point of inflection. So you need that test all the time. And it's one of the most common mistakes made. Students, when they get the second derivative being 0, they assume automatically they've got a point of inflection, and it's not the case. So I just stress again, very important to apply the test to determine points of inflection.